I hope you're learning plenty as we go through this course, because in this next section, we're going to be looking at cloud code. We'll start off with cloud functions. So what are cloud functions? The short answer is that cloud functions are how you run JavaScript code on the server side, rather than the client side in their browser. So cloud functions are basically server-side code, and the server-side code is not revealed on the client side. Because of course our front end, if we view the source, we can view all of our JavaScript functions hidden away in our JavaScript files at the bottom of our code. Server-side code is not accessible that way. So what's the point of them? Why do we need to use them? Well, there's lots of different reasons why you would use cloud functions, but one of the most common use cases would be for validating data that gets stored in our database. Another example would be efficiency. And being able to handle common and complex functions without putting too much of a load on your users having to download all of that code. And of course, security. So we'll look at all three of those different benefits. But when it comes to validation, we're making sure that certain objects inside of our database meet certain criteria, but not revealing specifically what that criteria is. Perhaps you want to make sure that the numbers fit within a certain range. Perhaps you want to make sure that strings are no longer than a certain length. Perhaps you want to make sure that the fields aren't empty, whatever it might be. You can run validation on the data that's attempting to be stored in your database. So that would be one use case for cloud functions. As your database grows and you get more and more data and objects stored in there, you might have hundreds of thousands of records. And if you're looking to query through all of that, that could be quite memory intensive. So if you were serving all of the data down to your client on the front end and then having them process all of that data on the front end to get the result they want, that might slow down the effectiveness of your app. So why not just push all of that code and have it all on the server side? So your client just calls one line of code in the application and the server processes all of that information over that side. It will just compress and reduce the size of your application. So if we come back to that security part, there are a few ways where we can secure our database using things like access control lists or class level permissions. But we've mentioned before that you can bypass all of that when you're using a master key. So if you had a class in your database where all of the data was completely locked down to the public, you would be able to search for that if you used a master key. But of course, what you don't want to do is you don't want to expose that master key anywhere in the front end of your application. So you would use cloud functions to be able to pass that master key through and complete those queries on that locked down data. So there are a few different use cases for why you would want to use cloud functions. You'll be using a lot of them. So let's jump into how we get started with them. So on docs.moralis.io on the left-hand side, scroll down to Cloud Code and then click on Cloud Functions. The very first tutorial that you should watch after this video will be this one here from Ivan. And the good news is, when you're defining cloud functions, they're all in JavaScript. It's built using the same as the Moralis JavaScript SDK. When you update your cloud functions and your cloud code, it automatically becomes available to mobile environments instantly. So you won't have to wait for a new release of the application. You'll be able to change the application behavior on the fly, and it will not slow down your development. And this text goes on to explain how you can reduce the bandwidth for a user that's using the application by processing things on the server side. Cloud functions accept a JSON parameters dictionary, so you can pass through items into your function if you need to. I'll show you how to do that more. But in this example, we can see here that the way that a cloud function is written is to write in the cloud code moralis.cloud.define, provide it a name inside of a string, and the function then passes the request object. And in this function, it's querying the review table. It's getting items where movie is going to be equal to whatever the parameter or the movie parameter was in the request, finds the results, and then there's a loop. And it's returning a sum of all the results divided by the results length to get an average. Okay, let's scroll down. Inside of Cloud Functions, there are some packages that are automatically available for you to use that don't require or don't need to use a require statement. And you can use the crypto package as part of the Node.js documentation. So down here, you've got access to all of these different classes that you could use, and there are hundreds. that you could use in here. So rather than going through all of those, because I don't think we need to do that, if you just pick a random one here, let's, I don't know, this one here. So if we look at one that we want to use, let's perhaps say this Diffie-Hellman generate keys. I'm not familiar with this, but we could probably do a simple Google search on that. And there will probably be some documentation somewhere. Wow, there you go. Okay, first shot, that's good. And so we could probably copy all of this. So I will go into our Cloud Function code. I'll just log in, so I'll speed this bit up. And once that's logged in, I'll go to my server, into my Cloud Function code, and we'll start writing a function in here. I'll just paste what I've got on my clipboard for now. Go back to the documentation, just get a copy of this code here, paste it in there, call this one crypto function. I'll just remove everything that's in there and replace it with everything we've just copied. The majority of it we don't need, it's just comments, but we'll ignore it. I'm not going to go through this line by line because we don't need to, but essentially what it's doing, it's requiring crypto, which we don't need to do. The DH is using the create Diffie-Hellman, and it's got 512 in here. We look at the documentation. This generates private and public Diffie-Hellman key values. You just need to provide it with an encoding string. We're just using the code that came with the example, 512. And then it's going to do some work on that. But at the end of this, DH key looks to be the item that we want to get back. So it's console logging that. So we're going to just simply return DH key. And in here, we'll just put crypto dot create Diffie-Hellman, because it's initialized as standard in Cloud Code. So we can now save that and go back to our front end. We can rerun it, and there you go. We've got a string back. You may never have come across that function before, but as you can see here, there are hundreds here that you'll be able to play with. And you might well find that you'll use some of those inside of your application. But to use them in a Cloud Function is super straightforward. Just put crypto dot whatever it is. Perhaps even Google it. Somebody's probably found a way of introducing that into a function some way. Okay, let's come back to our documentation. That in our Cloud Code, there were a lot of examples of console logs. That's fine in the front end if you're building front end code, but in the back end, console log does not work. So if you need some form of debugging or informational printing of messages, you can use this solution here. If I just copy that, go back into our code, I'm going to remove this function now because we don't really need this. I'm just going to remove that, and we'll just call this hello world. We'll initialize the logger here. I'll show you how to find the logger in a moment. And this is just going to provide a string of hello world in the log. So if I just save that, copy the name of the function, go back to our front end. Now, where is the log? Well, if we go to the dashboard where our database is, on the left-hand side, you'll see logs. And you've got an info and an error section here. This shows that our code is just refreshed. So we're ready to run that now. So we can rerun a function. We'll call that hello world. We're not sending any parameters in. It says undefined because we didn't return anything from our function. But if we go to the logs in the backend, you will see it here. Just refresh by clicking info, and it says ran cloud function hello world. And as you can see, there is the hello world message. If we go to our cloud function and just make one addition, just so we can show you how parameters might work here, we've got hello world, but let's just turn that into a template literal. And in there, I want to actually give it a variable that I want to pass it. So that will be in the request.params, and we'll just call it name. Okay, so we're going to pass a name into this function, and then in the log, it's going to say hello Chris or hello whatever name. Okay, super simple. But let's run that. So we'll save that now. But in here now, I'm going to pass in the name parameter, put it in a string, and run that. Again, you don't get anything back in the console, but if we go back to the dashboard over here, refresh that, you can see here it now says ran cloud function hello world, and it shows the inputs that you gave it. And we gave it a name of Chris, and there you can see it, hello Chris. All right, so that's a basic example of running a simple cloud function with a request parameter. And the request parameters you'll be using quite regularly, I would imagine. Okay, so that's the console log. Printing logs in real time in the console. There's a video here I recommend having a look at after this video. It shows you how to run a command where you can use the Moralis admin CLI get logs, and it will run a live real-time log printing function. We're not going to need this for the moment, but what we will need to do is configure our command line interface, because rather than writing cloud code this way, which is fine if you're happy to log into the dashboard each time and do that, but what you might want to do is set up cloud functions in your IDE. So we're going to go through this here where we actually install Moralis admin CLI and then watch a folder on our PC. So every time we write code in our function, let's say this cloud function file that I'm going to put together here, it will automatically update in the back end here. So we can manage our cloud code using our regular code editor. So let's head on over to Visual Studio Code and go and get this set up. I'll copy across this function before I do that and just paste it down here. Now I've created a folder inside of my project called Cloud, and inside there I've got a cloud functions.js file, and this is where I'll be starting to write my cloud functions, and this database.html file is the file that I was using to build all of the data in my database. In Cloud Functions, I've just copied this other one down here, and we've got some instructions that we'll need to follow. So we go back to the documentation. If you need any additional help getting it set up, there's another video here, but we are going to run this command in the folder that we're working on. Then we're going to run this command to actually watch my cloud folder, and then afterwards we'll be able to start running cloud functions from inside of Visual Studio Code. So I'll copy this one first of all. I'll go over to Visual Studio Code. Now I'm going to right click on cloud and open that in the integrated terminal. And I've just realized, now I'm using a Windows PC and I can see here that it's opened up a PowerShell. Now, I've had problems with PowerShell before, so I prefer to use the command prompt to run the command I want to run here. But that doesn't open up normally in the folder that I want to be in, so I'll just cd into cloud. Here we go. Make sure that I can see the cloud functions.js. I can. I'll copy what's on my clipboard to npm install -g Moralis admin CLI. This tutorial assumes that you already have Node installed. It doesn't take long to run this, only a few seconds. But once that package is installed, you'll be able to run the other command. Let's go back. Copy that. Now if I just paste it up here, just so you can see it, Moralis admin CLI, we're going to run watch cloud folder. You need to provide your API key here, your API secret here, and you need to change this to a specific path to that cloud folder that you want to watch. So I'll get the cloud folder code first of all. I'll copy the path, delete that, and inside of a string, I'll put the folder path that I'm looking for here. Next thing I need to do is go over to my server dashboard and go and get my API key and my API secret. You'll see the details you need in here. API key, API secret. Copy those. And once you've copied those, collect that whole piece of code onto your clipboard and then run it. It will ask you which server you want to watch. And for me, it was the very first one. And that is now done. So if we go back to the dashboard into our cloud function, you'll see that it's added all of this extra code at the top and this exports at the bottom. And you'll see that what's included in here is what I had from my Visual Studio Code. But it was before I saved it, so I just have one function here, the test function. But if we go back to Visual Studio Code, we'll see that this is unsaved because I added another function. So if I save that, you can see that changes have uploaded correctly. We'll go back, and now we will see the other code in here. Excellent. We now no longer need to use this window to write our cloud functions. We can do it directly from Visual Studio Code. How good is that? So down to calling cloud functions. Well, we've already jumped ahead a little bit there because we did do that once already. And you'll notice that in this example, they've built a parameters object, and inside of that object, they have movie as the key and the matrix as the value. And then they've passed that parameters object in as a second argument to moralis.cloud.run. And in this example, average stars was the name of the cloud function. We don't have a cloud function called average stars, so we can't really run this snippet. In general, there are two arguments that pass the cloud function, and that's going to be the request and the parameters. But you can also get access to request.user inside of Cloud Code, where you can pass back the user making that request. So what do I mean by that? Well, if we go over to our Cloud Function code, by habit I was about to do that, but we'll do it in Visual Studio Code, and we can actually just return an example of what I mean. So we could return request.user. So it should provide us with an object, the user object, for whoever runs the request on our front end. So I'll save that. We'll just wait a few seconds for that to upload. And if we come back to our front end, we've refreshed the application. And in here, if we just rerun that function, now we don't get undefined. We get the request.user. We get the user object. Albeit this particular function is incredibly basic and it's not actually getting any data from our database yet, but it just shows you how to construct a function and how to get information from the request. Okay, let's continue down using the master key in Cloud Code. So the master key is pretty much your most important key. Never expose this in your front end application. But there'll be times, depending on what it is that you're searching for in your database, if you're doing a query, for example, where you'll need to pass that inside of your Cloud Code. And you just simply use this object here. That'll be an example for the find method for a query. You've also got an example here for the save method on an object, or save all. And it's generally always going to be the same. Use master key true. Okay, so let's move down to implementing Cloud Function validation. We ran a very, very simple function in our Visual Studio Code, which just had the name of our function, what we wanted to do, but there is a third argument you can pass, and this would be a validation object. And a validator object in this example here would be this one right here. And it's using two specific options. It's using fields and require user. Require user just means that somebody needs to be authenticated. And fields, it's checking the database for movie. And really all this validation is doing is just making sure that there is a movie field. So the movie field is not empty. So inside of this request, there is a movie field. That's an example of simple validation. Let's take a look at it as an example in our own application using our database. So we go over to our dashboard browser, go to our unit table. Let's pick an example of a cloud function where we're going to sift through all of the data in our database and return every one that has movement points equal to 6. So we're going to need to define a cloud function and then return the results that equal that query. A few things to do. In our Visual Studio Code, let's write that out. I'll just close the terminal here and write a new function. I'll just remove that validator object for that previous function because we're not going to use it in there. I'll copy this function and we'll use this one. I'll call the function movement. Okay, so let's construct a query. So we'll call this query, which will be a new Moralis query. And which table do we want to search? Well, we want to search the unit table in our database. And that query, we're going to be running an equal to constraint because we want to look for, I think it was movement points, which was MP, where that's equal to 6. Let's just call that res, and we will make that equal to await query.find. Don't need to worry about the master key here. And then we could return and see what we get back from that. Chances are we're going to need to drill down into some data because this might return more data than we need, and we'll just try and carve off all of the things that we don't want. If I save that, Moralis.cloud.run will run our movement with no parameters, then nothing we need to pass through. Okay, here. So we can see that we get our response. There are 12 objects that would fulfill the criteria, but you can see here we're getting all of this extra data that we just don't need. All we really want will be contained in the attributes. So we kind of want to return a different version of this array, removing all of the data that we don't want. So we could use a map. As an example, we could just create a result, let's call it. So we're going to take the res, we'll map it, and for each unit, we'll provide back the unit.attributes. And assuming that I haven't done any typing mistakes, we can now just return the result. Let's see if we get any errors. We'll save that. Again, if you try and run the query too quickly, you'll get this kind of error here. But if you give it some time to run, and make sure you run the right function, because I've just realized I ran hello world there and I didn't mean to. But after all of these errors, it actually did run my function. So after running it again, this is return 12. And inside that, this is a new array. And now you can see all of the attributes. You don't have any of that extra data that you didn't need. And these are the results. And all of them, movement points, will be 6. Superb. Okay, but maybe what we want to do is have this a bit more dynamic. So rather than hard coding in to our query that we're going to be wanting to find movement points of 6, maybe we want our parameters to decide what we want our movement points to be equal to. So in our request params, we could send through a number which it will check. For now, let's just change this 6 to request.params, and we'll just call it points. We can call it anything we like, but let's just call it points for now. Save that. We'll go back to our front end, and inside here now, we can send it some parameters, and it was points that we were going to send. So maybe we'll try and send 5, just so it's a different result to before. So we could rerun that. We get 12 back again. And this time, these are for 5. Let's try and run another one with maybe 4 instead. 15 in this one. Maybe run another one with 3. And there are none. Another one with 7, let's say. And again, there are none. Okay, so just a bit of simple maths here then. So we can see that 5 points, there are 12 records. 4 points, there are 15 records. And for 6 points, there are 12 records. So if we add all of those together, that is 39 results. But in our database, there are 60. So we are missing 21. Why do you think that is? You want to pause the video and try and figure that out? If you haven't already figured it out, then the reason is because when we run cloud functions, are going to be coming across as public. If any of the objects in this class have an access control list, then the cloud function is going to fail it, because the cloud function is not a user, and the cloud function is also not a role. So it will fail the access control list. And there are 21 records here that have some form of access control list. So we saw 39 because it was publicly available, but we didn't get the other 21 because they had an access control list. Make sense? So how do you bypass an access control list? We've said it before. You use the master key. So if we go back up the documentation, and we'll just go and collect this master key object here. This is the example of how you would use it inside of the find method for your query. So we'll go back in here and we'll just put the master key in there. That's going to bypass the access control list. So now we should get a lot more results from our cloud function when we save it. Okay, so if we research 6, there are 19 results. Let's go with, should be none for 7. Should be none for 3. Should just manually change the numbers. I'm just going back through the old one. So 20, 21, 19, well, that equals 60. And there you have it. So we're allowed to run a search for 3 and 7, even though it's not going to return any results. So we're effectively wasting a call to our cloud function by trying to run something with it returning nothing. So what we should be doing is adding some validation on this function. So if the request comes in for an invalid input, like a 3 or a 7, then it should throw it out and not allow that query to run. And that's what you would use the validation object for inside of that third argument for the cloud function here. So let's run some validation here back in our documentation. So this was the simple example that you could use, but we need something a bit more than that, because just having a field is not enough, because we need to make sure that our number is either a 4, a 5, or a 6. So in the documentation, there's a more advanced validation example here, where actually they've nested more information inside this field, and that's what we want to do. So we'll copy the entire object, and then we'll edit it, paste it in here. So we're actually using two options. We've got fields and require user keys. Well, we're not going to use the require user keys. We will use the fields, and our field is going to be called HP. Is it required? Yes. What type is it? Well, it's a number. You don't need to put this, but if you want to, you can. And in here, in our options, we can actually provide some logic. So the value that we get back, we want to return a Boolean. Is it true or false? Is, and then we can do some logical expression here, and we'll maybe use an AND operator. The value is greater than or equal to 4, and value is less than or equal to 6. The error here, we could just simply say, must be between 4 and 6. So let's see what that does. Okay, we've got an error. Validation failed. Please specify data for HP. I needed to put MP because it's movement points, not hit points that we're looking at. That's my mistake. And the error is actually, again, mine because it's to do with the request and it's points that we're sending through here. So perhaps we should even just change our code. We'll just change this through to MP. And then in our front end, we'll call MP instead of points. And then everything will connect up nicely. So in here, we'll just change points to MP because that's the name of our field. And here we go. The error now is saying must be between 4 and 6. Let's try it with 3. Should also error. It does. But if we try and send it with 5, then we get our response. So that's one example of how you could use. You can add together and chain together different ones if you wanted to. So if we wanted to do a query with XP instead, maybe our query is going to have something where XP, we're going to do a less than XP. So we're going to put in, maybe we're going to search for where the XP is less than 40. So maybe our movement points need to be 5 and our XP needs to be less than 40. Whatever you want to choose. And we can do our validation in here as well. It's also a number, and it needs to be between, let's have a look at an example in our XP field. Our lowest is 30, our highest is 60, so we'll say it's between 30 and 60. There we go, 30 and 60, and we'll just say it must be between 30 and 60. So now we could pass in a couple of different parameters. We could pass in an MP or an XP parameter. In actual fact, we must because they're going to be required here. So if you don't pass them through, it will fail. We'll save that, go back to our front end, and this time we'll run a search for just MP, knowing full well this will fail because it wants us to specify data for XP. And so let's say this particular one, we want to look for anything where it's, I think it was a less than was the query, less than 45. So there are 8 examples in this case where XP for the particular user needs to be less than 45. Can't see the XP in these ones. Maybe just for the sake of an example, because we can see it quickly, I'll just change XP to HP, which will be the hit points. 65 is the highest, 20 is the lowest. Okay, so it's between 65 and 20. Just go back here. We'll change this to HP. 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 20 and 65, I think we said. All right, okay. That's just to make it easier as an example. That's the front end, and we'll just change this to that. Okay, so in this example then, this is all of the results where movement points were 5 and hit points were less than 45. And you can see the results here. You can see them quite clearly. If we try and do a search where the hit points are too high, we'll get an error. Or if we search for where the hit points are too low, we're going to get an error within the validation fields, and you'll get results. Now I've just changed movement points to 4, hit points less than 35, and these are the ones that you would want. Okay, now your data is going to be different to my data, so I appreciate that you might not have all of this in yours. It just goes to show how you can search your data for any type of field that you want and use cloud functions to return the data to you. So far, we have constructed cloud functions. We've understood the request, the parameters, and the request.user. We've also understood the validation object, how you can use constraints from how you can use queries inside of a cloud function, how you can pass the master key through, and what happens if you don't. There's lots of different things that we've covered there. And we've really only scratched the surface on what you're able to do with cloud functions. You as a developer will find all different kinds of use cases. And in the forum, there are lots of examples of how you can use them in different ways as well. We've even got our own examples, our demo applications in our GitHub repositories and YouTube videos that would have used cloud functions in some way that now should make more sense to you after having seen these basics. So that will be our validation covered off. And in this example, before data is being saved to this Moralis user, it's checking that it has an account type set. And the default would be viewer. Maybe they have certain permissions over somebody else. Maybe they have a role, for example. And constant, which is whether the field is immutable or not, is true. And you can see that the full range of options for the fields are explained down here. Okay, so that's just an example using a trigger here, which we've not yet come on to. All right, excellent. Let's see what this one is. So you can also pass a function to the validator. So down here, we've got two examples of where they've defined a cloud function called admin function. They would do some code in here, and then the validator, it's not an object, it's a function. And the function is up here. Just be aware that the validator runs first before your cloud code. So if you run through a really complicated, expensive function, then it's going to just delay the time it takes before the cloud call will be able to run. Okay, and so we have called our cloud function using our front end code, but you can also call cloud functions with a simple GET request. The URL would look something like this. You need to pass in your full Moralis server, followed by /functions /the cloud function name, and then pass your application ID and any additional parameters that you want to. So in this example, it's going to be running a function called hello, passes through an application ID, and it's going to pass through a name parameter of cryptochad, which is a string. Whenever you're using this particular option, you have to be aware that the parameters are always going to be strings. So inside of your cloud code, you're going to need to handle that and perhaps transfer them back to different type of data, for example, a number. Let me show you what I mean real quick. I'm going to come to this example here because it's simple, hello world, and I'm going to pass in two parameters here. And in here, I'm just changing this template literal here to hello name. Your favorite number is number. Save that. We'll go back to the front end and then we'll run that function. We need to pass, I think we called it num. We'll just put in a random number. We'll go over to our dashboard and see what it comes back with. Hello, Chris, your favorite number is 54. Okay, great. So you'll see here that the input for that cloud function call is correct. The name was Chris, which is a string. The num was 54, which was a number. So let's go ahead and convert that to a call that uses an API. Back to our front end. In here now, rather than await moralis.cloud.run, we're going to need to convert this into a query string and fetch it. We've got to build that query string. We're going to need the application ID and some other numbers. And I've just prepared the fetch here. So this is a URL string that uses my server. It looks inside the functions for hello world. I've got an application ID, and then I am passing the parameters of Chris and the num 23. If I press return on there, I've just realized that console login doesn't do anything because it's all going to go into the server logs. So if we go to the info here, refresh, I ran an example of that before, and there it is. Hello, Chris, your favorite number is 23. And you'll see that before, when we originally did this in our code, down here, the input, let's see where I can find it, here. The input originally was name, Chris was a string, number was 54. But in this example, Chris is a string and num is also a string. Now the result is the same. You could get some unusual results if, for example, your filter is looking for a number and it's being fed a string. So if you were looking to run a different function, let's say I was trying to run this movement function and I was trying to pass 23 into this function here, this HP or this MP. Well, maybe not MP because it needs to be between 4 and 6, but HP, if I was trying to pass 54, let's say, as a string into this, then it's not going to provide any results because it's going to be searching a field that has numbers in it for the string of 54. So inside of your cloud code, you'll need to do some conditional logic to search the request.params.hp and convert that to a number. Not sure what I mean? If not, let's just quickly run this. So the function was called movement. We can change this to movement. And I may get an error with this one, but I think we can just remove all of these handle parts. And I think I need to pass in, was it movement points? 5. And what was the other one? Hit points, I think it was. And we'll just say something like 54. Okay, we get an error. So let's see what the error is. Invalid type for MP. Okay, let's go back to our code. Well, of course. Well, this is the perfect example. So our MP and our HP fields, they are required, and they're required to be under the type of number. But of course they're not. They're strings. So we could turn this to string, or just remove it, in fact. And we could rerun that query. And then when we rerun that query, it does run. We'll go back to the dashboard, see what it says. We can see that we've got movement points, string of 5, hit points, string of 54. What does it return? Nothing. What should it return? Well, we could change this to 5 and 54. It should return 13 results, but it's not returning anything because it's looking for these as strings. And of course, there aren't any. It's numbers in there. So inside of the cloud code, you'll have to convert these strings to numbers. I'll give you an example. So maybe the new HP would equal the request.params.hp, and the MP would equal the request.params.mp. And you could convert those to numbers. So you could just simply do this. Or you could have some sort of conditional logic that says, if it's a string, if type of is string, however you want to handle that. And then you'll just pass in these instead. So we'll see if that works. Okay, it works on the front end. Let's see if it works with the API. We'll go and check the logs. And there you go. We got all the results back. So now we can actually change the way we handle this by just adding in all of these once more. And there you have it. There was 13 in this version, and now there's 13 in that version. So we had to do a little bit of work to just convert it. Well, I personally ran up against that issue myself. Great. So that's how you're going to call your cloud functions using the REST API. Okay, Web3. Now, Web3 functions are available within the cloud code automatically. You'll just need to initialize a new Web3 by chain instance. So depending on whichever chain you're going to be using, perhaps it's Ethereum, inside of your cloud code, and that's the key part here. Don't try and run this from the front end. It won't work. You can initialize Web3 by running this. It won't do that much on its own because the reason you're going to be initializing Web3 is to utilize some of the functionality. For example, constructing a contract instance like this, as Moralis does bundle the Open Zeppelin API for ERC20, 721, and 1155 contracts. And so you could bring that all together by using an example like this. Now, if you need a specific course around smart contract programming, there are YouTube videos available on our Moralis YouTube channel. There is also a smart contract course, I believe, in the Moralis Academy. But if you need more information, then post it in the DAO, request it in our community, and we'll do what we can. And that brings this first section to an end. We've gone through a lot of information there. I hope a lot of things were starting to pull together, and there were a couple of aha moments. Play around with the cloud functions. Explore the validation object, and once you had a look through all of those videos up the top, then come and join me in the next section, which will be HTTP request.